The problem is 1 plus iota root 3 upon 1 minus iota root 3 to the whole power n is an integer. This is an integer. Then n is, the value of n is 1, 2, 3 or 4. One of the answer. Now we will see the solution. One plus iota root 3 upon 1 minus iota root 3 to the whole power n. We will divide the numerator, divide the numerator and denominator by 2. So we get here 1 upon 2 plus iota root 3 upon 2 divided by 1 upon 2 minus iota root 3 upon 2 to the whole power n. Now 1 by 2 is cos pi upon 3 and sine pi upon 3. 60 degree is root 3 by 2. Cos pi by 3 is 1 by 2. Sine pi by 3 is root 3 by 2. And here in the denominator also cos pi by 3 minus iota sine pi by 3, which is equal to cos pi upon 3 plus iota sine pi upon 3 divided by cos, we will write this, cos minus pi by 3 plus iota sine minus pi by 3 to the whole power, because cos minus theta is cos theta, sine minus theta is minus sine theta. As we know, in the when theta is rotated clockwise in the fourth quadrant, cos theta is a positive, sine theta is a negative. So sine minus theta is minus sine theta, cos minus theta is plus cos theta. Now we will use here the De Moivre theorem. So this will become cos n pi upon 3 plus iota sine n pi upon 3 divided by cos minus n pi upon 3 plus iota sine n pi upon 3. De Moivre theorem used here. We know cos theta plus iota sine theta to the power n is cos n theta plus iota sine n theta. Now we'll use the Euler form here. E raised to the power iota n pi upon 3 divided by e raised to power minus iota n pi by 3. We used because of Euler's form of the complex number. Polar form is changed into, this is the polar form, so it is changed to Euler form. E raised to power iota n pi upon 3 and this is negative, so they will get added. E raised to power iota n pi upon 3 plus iota n pi upon 3, which is equal to e raised to power iota 2n pi upon 3. Now this should be integer. Now see in the polar form, cos 2n pi upon 3 plus iota sin n pi upon 3, 2n pi 3. Now this imaginary part should be 0, and uh, if n is equal to 3, if we put n is equal to 1, then imaginary part will not be, this will be some, this has some value. So this and real and imaginary part both have some value, so this is not a pure integer. So in order to make this real imaginary part 0, we have to put the value n equal to 3, and sine 2 pi will be 0. So this will become, if n is equal to 3, cos 2 pi plus iota sine 2 pi, and sine 2 pi is 0, this is 1 plus iota 0, so this is 1, and this is integer. Therefore n must be 3. Hence the correct option is 3, because if we put 1, 2 or 4, the imaginary part will not be 0 and it will have some value, so this will not become integer. Its value will be integral if only if n is equal to 3. So this is the correct answer for the question.